Good day, ladies. Today we're going to look at one of our separation techniques labs, and this involves the removal of an impurity of sodium chloride from a sample of iodine. So what you have in front of you is all of the apparatus that will be required for this experiment. So I need you to make a record of it because it is not indicated in your lab, but in your lab script, but you should, based on every single thing that we do today, make a note of the apparatus and the materials that we're using. So in this beaker here, you are seeing a sample of our mixture. This is our iodine, and note the color of the iodine. It is a bit of a yellow, an orange color. And so we have a sample of our iodine, and what we are using as our solvent for our solvent extraction is 1,1,1-trichloroethane. And so what we're going to do is follow along with all of the steps in the method and see how our solvent extraction works. So one of the first things we need to appreciate about our solvent extraction is that the apparatus that we use for solvent extraction is called a separating funnel. Now, if you remember, and I hope you do, the way that a separating funnel works is that it separates solutions of different densities. And so we will have two solvents in here, one an aqueous solvent and one a non-aqueous solvent of varying densities. And our separating funnel is going to separate our two mixtures at the end of the experiment. Now on this side, we have our stopcock, and our stopcock is a simple tap that turns. Once it is perfectly in line, parallel to the tap, then this is open, and when we turn it horizontally, which is now perpendicular to our tap, this is our closed. So anytime we need to use our apparatus, the first thing we make sure to do when we are filling it is ensure that our tap is closed, which is perfectly horizontal. When we need to open it to let any solution out, we're going to just turn it so that it is now perfectly vertical. Another feature of our separating funnel is our stopper. Now this stopper is very important because it allows us to cover it and do the shaking that needs to happen with our with our two mixtures, our solvents inside of the separating funnel. Now as this experiment proceeds, we're going to have to, as you're seeing in your instructions, we're venting. The way that we vent is by turning our separating funnel upside down, keeping a finger on the tap, and then we're just going to vent by opening this, making sure that it is in the upward direction, not pointing at anybody, so that any liquid or fumes that come out of here are not going to end up in your eye or your next door neighbor's eye. So we're just going to take some time. So the way that I have this mounted is that at the top, this is what I have attached to my clamp. I'm not clamping at the bottom here because it's not very stable. So my clamp, which you cannot see on the board, is holding my separating funnel at the top here in a very stable way. So I'm mounting my separating funnel onto my clamp stand, my retort stand, so that I can start adding my solutions to it. So here we have our solutions, both of which have already been measured out. I have on this side, this is my 25 cubic centimeters of my mixture, my sodium chloride and iodine mixture. This is my iodine with the impurity of sodium chloride. So we're trying to remove the sodium chloride from it. And over here, we have a clear, colorless solution, which is our 1,1,1-trichloromethane. So remember, I said one of these in this mixture, in this experiment, we're going to have a polar and a non-polar solvent. So based on what you know about polarity, polar and non-polar solvents from Form 3, you should be able to make the inference about which of these is going to be the polar solvent. Again, I have some sodium chloride and some iodine dissolved in water, and I have some 1,1,1 trichloroethane here. Okay, so first up, we're going to take our filter funnel, and again, I have made sure that my stopcock, my tap is closed because this is perfectly vertical. I do not want to start pouring solution into here and have it run out because I've not paid any attention. So I am pouring in my mixture. And to that, I'm slowly going to add some 1,1,1 trichloroethane. So remember the color of the 1,1,1 trichloroethane. Why I am doing this is because I'm trying to ensure that my trichloroethane just runs down the side. I don't want it splashing. This is why they're saying gently add, slowly and gently add my solvent, the other solvent. So I've added the 20 cm cube of my 1,1,1 trichloromethane. So what you want to make note of here are the colors of the different layers of solution. So this is what your first observation is going to be. We have in here two layers, a bottom layer that is orange or yellow-orange in color, and we have a top layer that is colorless. And that top layer, based on what we know we've just poured into this separating funnel, you should know what is what. So in your labeling, you're going to state what exactly is in this bottom layer, which at this point we know that that is our sodium chloride and iodine and water, and our top layer is going to be our 1,1,1 trichloroethane. So what I'm going to do now is remove it from our clamp and shake our mixture. So this is, my hand is on the stopper and I've turned it completely upside down and I'm shaking it to make sure that everything gets mixed together, and I am venting by keeping it upside down. And the purpose for venting is to release any air that would have gotten trapped in this. Because when we mix solutions of this type together, what tends to happen is that the high volatility of something like an organic compound will tend to make it form vapor, and this venting will allow any of those vapors to escape safely. If I do not vent, what can happen is that my cover will pop off, and I do not want that to happen at all. So look at what's happening here. What are we noticing? Remember what it looked like before I started to shake? Giving it a bit more of a shake. Now this tends to take some time, which we're going to use movie magic to go through faster. But I want you to appreciate. So what I'm going to do is just let this, so we're going to put it back onto the clamp stand where it can safely settle. And in order for this to settle, what I have to do is remove my stopper up at the top. Because once I remove my stopper, you'll see that these mixtures start to settle a little bit faster. So we're just going to give it one last shake with venting. Remember, the purpose for venting is to allow the release, the safe release of any gases that might build up while this shakes. So here is my mixture. I've turned it upside down completely. And this is my vent opening up. So really, I could either do an invert mixing situation, and when it's upside down, give it a shake. One last venting. Now this is not a perfect situation. Again, there are limitations to what we can do in the lab right now. And this will, if we, those of you who come back for sixth form, ideally we would do this several times and pour out the solution. But what I want you to notice is this. This now is your second observation. So you're making note of what is in the bottom layer, its color, and what you think is now present in here. And now you have a top layer, its color, and what do you think is present in here. Now remember, this experiment is using solvent extraction. And we're using one solvent which will be able to dissolve one of our solutes to extract it from the other solution that it was in previously. So we started off with a mixture, this color. Now look at the relative intensity of the color. Now if you think about what is causing the color in here, what would be causing the color in this mixture? And based on what is causing the color in this mixture, if we now compare it to what it looks like at the end of the experiment, what has happened to that color is an indication of what has happened to the thing that creates that color. I'll say that again. What is causing the color in here, making it a dark color? Remember concentrations, if we have a colored solute, the darker the solution, the more concentrated it is. And now this is less concentrated here than it was to start off with. So what has happened to the solute? And so considering that we have two different types of solvent, one of which is going to be able to dissolve the solute much better, I'll say that in a different way. Our solute, while it is soluble in one type of solvent, the solvent here, it is more soluble in the solvent that was here. And so think about what has happened. So what we've been able to do is extract the solute from here and bring it up into this next layer here. And so this is why this is coming up as purple. So when you record your observations, you are recording what this color is, as well as what it is containing. You are also recording what this color is, as well as what it contains. So in order to separate this, again, what we would do is separate, and we'd pour some off, we'd allow some to tap off, and then we'll do this several times with the shaking in between. And ideally, what we want is that this bottom layer goes completely colorless. We want this bottom layer to have as little color as possible, because we want this solute, the solute that is in here, to be in this layer at the top here. So I'm going to just tap off the bottom layer. And we do that by simply opening our tap into another container and paying close attention to when that top layer reaches our tap. So I've separated my two solutions, and now I can take another beaker and tap this off and remove it and put it aside. Yes? So this, ladies, is an example of your solvent extraction, where we use one type of solvent to extract a solute from another solvent in which it is less soluble.